Hello everyone. In this video, we are going to discuss about how inter-process communication takes place in the message passing model. In our previous video, we have already discussed how inter-process communication takes place in the shared memory model. Now let's look at the diagrammatic representation of the message passing model. This diagram A depicts the message passing model, and diagram B depicts the shared memory model, which we have already discussed in our previous video. Now, if you look at the first diagram, now process A and process B are the two processes that want to communicate with each other. Now, these two processes are going to communicate via a message queue. So, they will be posting their messages in the queue, and each process in turn will be able to read the message from the queue as well as send messages through the queue. Now, we are going to discuss in detail about how this message passing is going to take place. What are the different ways or techniques or methods by which this message passing will take place? Let's move further. So the message passing system is nothing but it is going to make use of two main operations. One will be the send operation and the other one will be the receive operation, send message and receive message. Via these two operations, IPC between the processes is going to be enabled, and the size of the message can be anything. It depends upon the system, the application which is using the messages. The size depends upon that. Therefore, the size of the message can either be a fixed size or it can be a variable size. Now, let's move further. Let's take that we have two processes, P and Q, and they want to communicate with each other. So we have one process P and another process Q that wish to communicate. So what should be done in order to implement this message passing model? First, what has to be done is we need to establish a link, a communication link between P and Q. And once the link is established, then messages can be exchanged through the two operations which you have already discussed, that is send and receive, via the link that is established between P and Q. Now, what are the issues that lie behind the implementation of the communication link? Now, the first issue is how are we going to establish the links? The next is whether this link is only going to exist between two processes or is it going to be associated with other processes also. And another issue is how many links are going to be existing between a pair of processes. What is the capacity of the link? How much of data can it hold? And is the size of the message fixed size or variable size? That is another issue. And the link nature, whether the link is unidirectional or bidirectional. So these are all the implementation issues. We have a total of 6 implementation issues that are existing with respect to the establishment of a communication link between the two processes that want to communicate. Now let's move further into the implementation of the communication link. So when you take the implementation of the communication link, the first kind of an implementation that we refer to is a physical connection, establishing a physical connection between the two processes. So physical connection can be established through shared memory, or it can be through a bus or the network. So these are all the ways in which physical connection can be established between the two processes. If you want to implement a link via a logical connection, then these are the 3 ways. You can either use a direct communication or an indirect communication, a synchronous communication or an asynchronous communication, and an automatic or explicit buffering technique. So these are the different ways in which the communication link can be implemented. Now let's move on to direct communication. We are now going to look into the logical part, the logical implementation of communication link. Like in the previous slide, we saw the different ways of the logical implementation. First one is a direct or indirect communication, synchronous or asynchronous, and the buffering technique, that is automatic or explicit. Hence, now we move into the logical implementation part in detail. The first one is direct communication. That is, if your link is going to be established through a direct communication link, then how is the process going to communicate between each other? That is, if we took as example two processes P and Q. So what the processes must do is the processes must name each other. So if the process wants to communicate, then through the send message, P will send the message to, if you want to send it to process P. Receive Q comma message refers to you're going to receive a message from process Q. So this is what the two operations send and receive. The syntax of the two operations send and receive will be when the process name each other explicitly. And the properties of the communication link in direct communication is links are established automatically. A link is associated only with one pair, exactly one pair. And between each pair, you will not have more than one link. You will have exactly one link. And the link can be unidirectional as well as bidirectional, but mostly it will be bidirectional. This is your direct communication. Now coming to the other one, indirect communication. Now when there is going to be an indirect communication between the two processes, then what has to be done is communication between them will be done via what is called as the mailbox. So this mailbox will be the main item that will be used in the case of indirect communication. So every mailbox will have an ID. What the processes will do is, say for example, if P wants to communicate, P will put a message into the mailbox. And whenever Q wants to read, Q will access the mailbox and Q will receive the message from the mailbox. So this is how the two processes will communicate in case of indirect communication. Now, when it is indirect communication, how is the link going to be established? What are the properties of the communication link? Link will be established only when there is a common mailbox existing between both the processes. And you can have a link with any number of processes. And each pair of processes can share any number of links. Just the opposite of direct communication. And the link can be, as before, can be unidirectional or bidirectional. So this is about indirect communication. This is how in indirect communication your message is going to be transferred. You first create a mailbox. After creating the mailbox, you're going to send and receive messages through the mailbox. And once it is done, you're going to delete the mailbox. So the send and receive messages are defined in this manner. The A that is written here represents the mailbox. So send A comma message means you're going to send a message to the mailbox. And receive A comma message means you're going to receive a message from the mailbox. So this is how indirect communication takes place. And when indirect communication is taking place through mailbox, what is the major issue that might exist? So look at the scenario that is given here. The scenario that is given here is P1, P2, P3. Three processes are sharing a single mailbox. That is A. So three processes are sharing the mailbox A. And P1 is sending a message and P2 and P3 are receiving it. So we have a mailbox A who is sending, P1 is sending. And who is receiving? Both P2 and P3. P2 and P3 are receiving, are in the receiver end. So the issue lies here is who will get the message. So solution that we are going to provide is you allow a link to be associated with at most two processes, and only one process at a time must execute a receive operation, and allow the system to select arbitrarily the receiver. Sender is notified who the receiver was. So if these points are considered while implementing this, then we'll be able to find a solution for this scenario. Now coming to the next type of logical implementation, which is the which we saw as synchronous and asynchronous. So we are going to see how we are going to achieve the synchronous link establishment and asynchronous link establishment. So here, when passing takes place, when message passing takes place, it's going to be either a blocking nature, or it's going to be of non-blocking nature. Now, blocking is considered as synchronous, and non-blocking is considered as asynchronous. Now, when we say blocking, we have two types of send and receive. Blocking send, blocking receive. Similarly, when you take non-blocking, we have non-blocking send and non-blocking receive. What does this mean? When we take blocking send, it means the sender will be blocked until the message is received. That is, the sender, once it sends the message, it will block itself till it finds out that the receiver has received the message. Similarly, a blocking receive, when it knows that it's going to get a message, the receiver will block itself until it receives a message from the sender. This is called blocking send and blocking receive. On the other hand, when we talk about asynchronous communication, that is non-blocking, your send and receive will behave in a non-blocking manner, wherein the sender will send message and it will continue with its work. So it is not blocking itself. Similarly, the receiver will not wait till it receives the message from the sender. It will keep on doing its task until it receives the message. So this is called as non-blocking receive. And say, for example, if we say that both the sender and the receiver are blocking, then we say that we have a rendezvous between the sender and the receiver. This is about synchronous. Now coming to automatic or explicit buffering, wherein we are going to make use of buffers for establishing the link. So here we have three different ways in which it is implemented: using a zero capacity buffer, using a bounded capacity buffer, and using an unbounded capacity buffer. That is, when we say buffer, we know that buffer means it's a temporary storage area. So now we are going to establish the link between P and Q through a buffer. This buffer can be zero capacity, it can be bounded capacity, or it can be unbounded capacity. What does that mean? As P is sending a message with the zero capacity buffer, it will not hold the message. It will keep on sending it to the receiver. So this the zero capacity buffer will just act like a channel. But when it is bounded capacity, which means the buffer is of a definite size, then sender will not send if the buffer is full. Till then, the sender will keep sending. Unbounded capacity, the sender is never made to wait. It keeps on sending the messages. So these are the different types of buffers which are available for implementing the logical communication link establishment between the processes. So with this, we have seen how inter-process communication is established via the message passing model. So here we will end. Thank you.